Hi and welcome to episode 14, yes, of Every Semicolon. I'm just opening up YouTube to double check that I'm correct about Every Semicolon being up to episode 14, because that seems like a lot. Okay, very true. Alright, so this episode, what I want to do is the thing that I've been forgetting to do for a while. Background, get rid of that, and that is the aiming power setting doodad. Yep, doodad. So at the moment when you play the game, there's these really awesome vertical sliders which I hate. They don't live up to their awesome reputation. I need to do something about that ballista bolt at some point, but yeah, so what I'm going to do is get rid of those and replace them with some sort of, again, doodad that allows me to aim, tilt the ballista up and down, and bring it back and forth from the ballista to change the power. So my intention is to use the same system on all weapons, but all weapons won't have the same capabilities. So the ballista is one of the ones that will be able to tilt, versus something like a trebuchet. I don't believe will be able to tilt, be more of a power thing. So actually the trebuchet, yeah, I'm not really sure how the trebuchet would work in terms of the setting the power, since the trebuchet is what slings down. Yeah, I mean you could just pull it in a direction. Catapults, similar sort of thing. So okay, and they'll probably just go out this direction. You pull it just this way to dictate power. So you have it like that, and you'll be pulling it this way, and boots. Alright. Just before I started this video, I spent a couple of seconds thinking about how I was going to do this, and my thought was that I would put in a plane like so, and this plane would serve as a raycast sort of plane. So what would happen is I'd come out here and I could have my sphere. I think it's going to be for now just a sphere, serving as like a button somewhere on this plane, in this axis, in the ZY axis, and as I raycast to it from this perspective, I can then shift the sphere around on that plane, and what that means is that I don't have to worry about any sort of calculations I'm keeping on that plane, or any distance stuff. I just raycast. If I hit that plane, then I can just do some checks to see distance and angle and that sort of thing, and position the sphere accordingly. So that seems like the go. I'll remove this plane because, again, I don't need the 10 by 10 plane that Unity provides. I'll use my Plano 1, old reliable. I just put that into the wrong thing. I want it in the mesh collider. And mine's on a different axis, so it doesn't really matter which direction it's facing. What we'll do is make it. So this will be part of the ballista prefab. So I'm going to stick with my newfound carefree nature of updating the ballista prefab, at least for the moment, and just update this one here. So let's have a shortcut for this. I gotta remember that. Okay, so this is the aiming collider. So it can go in there. and I want to give it a particular layer so that when I raycast, I can just raycast against that layer and speed up the operation. So I've still got plenty of layers to work with within this 32-bit bit mask. So I'll just use this use the layer 15 and call it aiming collider. Possibly no reason to have a parent, it's just sort of a waste, so what I'll do is actually just drag that out, just grab that name, delete that, and I'll just remove that there, and that, and now all I have is my mesh collider, and that's going to be big enough for my purposes. Yeah, so what I'm going to do is apply that for the moment, and then go to the weapon script, and we'll add a pointer, or a reference to that collider. Alright, it's a bit of a cluster here. So we've got animation stuff, weapon tilt points. Okay, we'll just add it after these aiming things. Whoop. Alright, so I'm going to keep a reference to the aiming collider, and what I'll do is I'll turn that, where are we living? There we are. I'll turn that on and off as I select and deselect the weapon. So there's only ever going to be one aiming collider game object in the scene activated at a time, and then my raycast can only hit one thing. Okay, next we'll put in again, we'll just do this as a child object of that aiming call it a button for now. I'm not sure what this is really ultimately going to look like. In fact, and I should just probably just chuck in a sphere. So I mean, we might put in some sort of line drawing between here and that in the ballista, and you can stretch it and you can see what's going on, or I don't know, something cool. All we really want for now is just a graphical element. Our collider has scale of 50, so this one's now coming with a scale of 0.02 to maintain its 1 meter size. Let's just bring it up to 2 meters. Alright. And we'll go to our weapon. Alright. Now, I was thinking I would just make it so that you can click, and if it's within the valid range, then the button, I guess, will appear there, and it would still allow you to sort of have the illusion of clicking and dragging on the button and moving it around. I'm not sure if that's going to be the best idea. That's what I'll do for now, and if it ends up being that you need to click on the button first to move it before you can move it, then I'll put the collider back on it and I'll test for that raycast as well first, and if that succeeds on mouse down or on touch down or touch started, then I'll allow this thing to occur. So let's get into it. Weapon, projectile, territory. Actually, we probably should do a separate script for this. So I'll quickly do a aiming. It's aiming. It'll do aiming script. And I'm going to drag out let's just forget that for the moment. I should probably do at some point, and maybe I'll do a video, a very, very interesting video. We're actually going to do a bit more technical design analysis on what we're doing here, and break up the work required into different classes in a way that makes more sense, and then just rearrange things, reorganize things, so that it's better. You know, it's cleaner, it's more compact. Not, I mean, compact is not a better thing, but it's just cleaner and fits together better, makes more sense. Things are in their own appropriate classes. For the most part, it's not too bad. But just looking at this weapon script, it's getting a little bit big. And that's not very big yet, but just the amount of public variables in it now. So you go to look at this weapon. I mean, that's starting to get a little bit unmanageable. I don't really like to have that much stuff for one asset, one component. I'd rather keep it separated, more modular. Alright, so what we're going to do is go to our aiming button, aiming collider. So when we deselect this thing, do we have a deselect weapon, show top aim false. Let's go in here and go aiming collider enabled equals false, and aiming button dot. Well, let's deactivate the whole game object, and on select weapon we will activate them. In fact, no, let's only do this on the side view. Show top aim. What is that used for? Right. We want a similar sort of thing for side aim, so we'll just do that. And again, yeah, I don't want to keep harping on this, but I really shouldn't be taking so long between videos, because as you can see, I'm sort of continually wondering about things in my code, and it's really not ideal. Okay. Alright. Take that out. So, I don't know why I keep saying so and then taking a drink of coffee, or starting a sentence just as I pick up the cup. What we're going to do is, in the side view, so set camera side view, so blah, we currently draw those sliders, so we'll search for where we're doing that. It's not in the weapon script, or I don't know what I'm searching for. They're called sliders. I think they're called sliders. They're called, yeah, vertical slider. What was I searching for? Match case. Whoops. Okay. Okay, so when we're in the side perspective, we're drawing this silly vertical slider. Oop, we don't want that. We don't want that. We don't want any of this. Instead, what we want to do is our raycast method. So let's get rid of all of that, and instead call our method to do this side aim raycasting and that sort of thing. So selected weapon dot do side aim update side aim. We'll jump into the weapon and find a good spot for it. Again, some of this is a bit so down the bottom, and also have the thing separated into public versus private methods and things like that for a while. So now I'm starting to mix and match it a bit based on my change in region setup. So things aren't necessarily laid out in a way that I would see possibly as ideal in my current frame of mind in code formatting, but I mean really it doesn't really matter. There's no right or wrong way to do things. It's just sometimes some ways are better than others for particular situations, like in this case where I am doing these videos and talking a lot and not focusing 1000% on everything but what I'm doing. Sometimes I can forget things or not focus on where I'm going to put things or where I'm exactly what class I'm putting the code in. So for the most part, well, I've probably been fine so far, but I just need to make sure that I don't get too far down a path of not making enough classes, or making these monolithic classes and put myself on a real bad back foot for later in the project. So yeah, I mean the technical design video might even be interesting, maybe. I'll probably just do something like the Visual Studio's class diagram and just figure it out that way. If anyone's got any interest in that, then let me know. It's obviously a video that could be skipped if you don't, but I won't necessarily bother doing it if no one's interested. Alright, so side aim. We want to do this raycast. So what we're going to do is a physics raycast to the layer called aiming thingamajig, aiming collider. So the name aiming collider, that layer. Let me do add to the weapon script another wonderful public variable. This one called a layer mask aiming collider layer mask raycast layer mask. Don't know what the default sort of layer mask would be. So 0. Okay. So I want aiming collider, and I'll chuck in my button reference while I'm here. Wonder if the wonderful sound of neighbours doing garden work is coming across through the microphone. Hopefully not. Alright, so if physics.raycast, and we want to do which one of these we want to use? We're going to get the main camera, so is it camera manager dot main camera dot screen point to ray, put a mouse position, there's no real reason to put a limit on there. I could use infinity, but okay, layer mask. Alright, that'll do for the moment. Okay, so that's going to return true if our, well, we can also, we'll need to surround this. Yeah, so this is, I mean, obviously going to be on some sort of handheld mobile device, iPhone, Android, both, iPad. So I'm going to need to put in touch input stuff. Now I'm just putting PC input, just mouse and keyboard. What I will do in a later video is create an input manager, or bring one across from one of my other projects, which allows me to wrap a lot of this input stuff within that and access things a different way. So I can access the mouse position or the screen position, a touch position, through one common interface, making it so I only have to actually code the input stuff, implement it once, and just have a manager to handle, depending on the platform, what it's doing, what it's returning. So for now, this is stuff that I'm going to have to tweak a little bit later on then. So mouse button, so if it's just held down, just the left mouse button. We do want to do this raycast. Raycast hits the thing. So the next thing I wanted to do was add in limitations. So public vector 2. I'll just do it as 2. So min. What am I calling this? Tilt points, Y angle. Do I call it X angle? Okay. Let's say min X angle. So, yeah, I don't really want to confuse it with what is the actual range. But what this is going to be is, when I come out here, I'm going to limit so the amount the ball can go. So I can't put it up here, I can't put it down here. I can only put it within a certain range, angle range, from the back of this ballista. So I also then need to put in something, a distance, and I need to put a distance from point. It needs to be a centralized point here, so I need to maybe position this aiming collider, center it on where I want the ball to sort of be coming out from. Okay. So let's call this min side aim angle equals. We'll just do it from like up. So if we say 0, then the minimum angle would be up here, and then 180 would be down here, so you'd be able to go all the way around like this. So what we'll probably do is we'll just start off with the ballista. It can go straight, so we've got 90 and I think 25 degrees. Is that right? So we'll use Unity's vector 3 angle function, which doesn't return it just returns a 0 to 180, doesn't matter which direction it's going. So if we just use up, we'll never go more than 180. So we can go up, down to 90, and then from there to 115. We'll just see how that goes. And I'll just put these in as a defaults for the weapon script, even though this weapon script will be used on other weapons, but I'll just change their settings in the inspector. And we also need min side aim distance. This will be in, we'll do this in world units. No, doesn't matter. Now we're going to need to make this ball render in front of everything, so here we'll go, inside of the platform, but I need to still render it, so we can do that in a number of different ways. Get to that a bit later on. Alright, so we're going to get our position, the raycast hit, so we need to get a raycast hit object. Let's get info. Front. All right. Position equals hit info dot point, and we're going to need to have this going in a particular direction, so it's always going to be the same plane. I never need to do anything more than just this 2D plane, so what I'll do is just treat that as how it's always going to be, and know that the positive Y is set facing forward, negative Y is facing back. I'm going to make this a bit bigger. Bring our sphere back to what it was originally of 0.02 to get it back to 2 meter sphere. Alright, and I'll just hard code that positive Y value for the moment. No, I won't. I mean, just saying it, it's just not right. I'll put it in as a private variable though, because I'm not really too concerned about having to change it. Aiming collider forward equals vector 3 dot up. Vector 3 dot up being 1 y, so 0 1 0, which is so that direction in the plane's local space. So now I can get, if hit position dot, and also so my sphere is in a child of aiming collider, so I can utilize the fact that it's in its local space, and I can say if hit info dot position. So this is I want to get that in local space. So what I'll do is aiming collider dot transform dot world to local inverse transform. So now that's in local space of the aiming collider. And what we'll also do is actually make two variables here, so well, I'll just leave it. Just one for the moment, and I'll see what I'll need later. So in local dot y is greater than 0. I won't worry about using that vector 3 I made just before for the moment. I don't think I'm going to need to use it. I'll just again sort of hard code it. So if it's greater than 0, I want to set it to 0. So that way I can't drag the ball to the right of the center of the plane. Now what I want to do is get a vector from the center of the plane to that hit position in world space. So is there anything further I need to do? No, that'll do. Alright. The direction to hit points. Well, this is probably a bit strange, but I can do more optimization later if I want to. I'm just going to do this again, but just transform it back. And get the direction to the aiming collider. You can see here I've accessed transform 3 times already. I'm going to cache that. Swap these over. Alright, so that gives us our direction vector. We'll get the distance and we could use squared magnitude to speed things up, but again that's an optimization for later if we need to. Distance to point, direction to hit point, magnitude. We also now want to we'll just normalize this. Okay, now we can check the angle. Okay, so we're going to go from vector 3 dot up to our direction to hit point. And what we'll also do, we'll just do some tests now because we've been writing a fair bit of code. It's probably about time to I'm going to change that to the transform. Oh, it already is. Of course it is. What we'll do now, direction, hit point, position, world. Okay. Yeah, we'll just have a look, see what's happening. We'll just log out what we're up to. Log out this angle. Okay, raycast hit info equals null. We need to make this new raycast hit. Aiming collider transform is not what I called the variable. I spelt it wrong. Cool. And that's that. Whoop. Unassign variable. Aim collider transform, aim collider transform. That's fair enough. Let's do that for a moment. Although there was 4 of them, wasn't there? Okay, so I never assigned it even to my ballista. Yes, I did. Variable of aiming collider. Variable aiming collider of weapon has not been assigned. Aiming collider, collider. So let's apply that for a sec. Okay, we've got 4 weapons. Catapult, catapult, catapult. It's in show side aim. Alright. Let's do this. These are if statements we can take out later because we'll know that they will always be there. But or perhaps I can just ignore the errors. Maybe that's a better way, rather than putting in if statements that I'll forget to take out later. But it's not the better way because that then doesn't allow that function to continue properly and causes the game to stop. Okay. Right, so nothing's happening there. Let's have a look. Our aiming collider is activated. It's not set to the right layer. Hold on, I think I need to change that camera. Side view camera. Shift it over a whole bunch. Okay. Let's go to this. Change layer. Aiming collider, don't change the child. And apply that. Okay, so there we can see that our ball is going to where the mouse goes. So we have a limit of the plane size, and it's also being forced to be within the left side of the ballista. So far so good. So that's saying 90. That's just saying 90 all the time. Okay, that's interesting. Stop that for a sec. Alright, so let's have a look. Angle between vector 3 dot up and direction to hit points. Direction to hit point, we use the local space. Let's change that to world space. Okay, so 0, 180, 90. Okay, so that's much better. Okay. So now what we want to do is we can put in a limitation on the distance. So where is our distance? Distance to point. Distance to point equals mathf dot clamp distance to point between min that one max that one. Okay. Final position equals direction to hit point times distance to point. And let's see if that part functions. Whoa. Doesn't seem to be. I can't. Oh yeah. Yep. Okay, so that's not letting me get within 5 meters of it. Let's change these numbers and have a look. So min distance, make that a bit bigger, 10. And the side aim, put that 30. Okay, so 10 's working out. 30. And those aren't too bad of numbers. I think that might work out okay. Alright, so that part works. You're now limiting the sort of distance, and that will then this number here, distance at point, is then sort of transferred into, and we can do that now, the power. So if we go back to the game manager, what we were previously doing was shot force. Select open shot force, blah blah blah. Just grab this line and bring it across and see what we were doing. So shot force equals vertical slider. It's going between, and that's just the screen rect. And it's going between 1 and 0. 0 and 1. Alright. So our shot force, set power animation. Alright, none of that really matters. So what we want to do is get the distance to point and get it where it is between these two ranges. So like we've seen before, use just this. There might be a faster way of doing this, faster little algorithm for that, but for the moment I'm happy enough. Okay, now we can see our shot force changing based on how far I'm pulling that back. So that's pretty cool. Yeah, it feels a bit more tangible. We can pull back to get power and shoot. Alright. Wicked. Yeah, let's jump back into this. Okay, the next thing is to limit the angle. What I'll do is make use of this vector 3. I mean, this isn't necessarily going to be the fastest way ever doing it, but again, for the moment it's more interesting, or more important, to get the gameplay sorted out, because all this might change still. So if we yeah, okay, so up axis for this thing is X, right is right is the Z, forward is the Y. So what I'm thinking is we can have a vector pointing, vector pointing sort of up, and we can rotate it around sort of negative Z in this plane space to the appropriate angle, min and max angle, to get a vector in that direction, and that we can then clamp that way. So yeah, not super fast, but it'll get the job done. And that's private. First, let's just get it working. Let's just test it out. So direction to hit point is the one we want to change. Hit point equals, and we're going to want to try and do this in the space of that. Right, nothing really here for me to use. I might just instead do it with a bit of, I can use a lot of 2D maths in with this because it is only happening on two axes. Alright, so what I'll do is first clamp the angle, so angle equals mathf clamp angle between that and that, no, that, right, and I'll just do this all the time, this creating the vector. Angle, get the angle in radians. Okay. Let's get cos theta. We'll just call it cos angle to keep with this convention. I don't know. So we're going to get cos and sine of theta, the angle, and we're going to build our new vector, and it's on the I don't know what plane this is on, in world space. I might be better off doing it in local space. I'll do this in local space at the moment, and then I'll transform it, or well, for now let's just get it working, and then we can figure out how we're going to do the space stuff without so many transforms. So it's the ZY space for this particular weapon, but for another weapon it obviously won't be in world space. So ZY, Z being the X, Y being Y. So alright. Cool. Right, so I'll just do this like I'm rotating a 2D vector, even though I don't really need to have, it's meant to be radians. So okay, so let's do that, and then we'll have our up vector, our y, and we'll just do ux equals, okay, so the way this normally would work if I had a vector is you would do like the vector, the 2D vector x times cos theta minus y times sine, and then for y it would be the same except reversed, and with you'd add that. But in our case, we're going to be like rotating a 2D vector that was like this, So that's sort of unnecessary. So what I'll do is just take that out. Take that out, and then you see that basically all we want is this. And let's see what we get from that. Can't see anything resembling what we want. Let's jump back for a sec, and it will log what we've got here. We might just need to normalize the vector. Okay, so we got so it's on the X, Y plane. That looks like it's right. 1 on the X, 0 on the Y, so coming down, X decreases a bit, Y is going into the negatives. So it looks like it's right, it's just the problem is that it should be what plane was that? Z, so that should be a Z and that the Y. So our ball is probably somewhere. Hard to guess. On the it's on the wrong plane. So U vector 3 we wanted 0 negative sine angle, and it's a world position. It's a local position. It's a local position. We want to put that into world space. Again, we'll just do this for a sec. Okay, so the vector we're seeing logged down there looks right, but our ball is on the other side of the world. Alright. Okay, so we'll just which point would we say that was actually? Where's our ballista? World space, that's positive Z and Y, so let's do that, see what happens. Okay, and that's working within our acceptable range. Alright, so that works. We now need to, well, it's sort of jittering around a little bit, and we won't worry about that for now. We now have got to hook it up to the angle, and then we'll need to make it work on any weapon of any weapon facing any direction. So just do it all in local space. Okay, so we'll delete that. Now we've ended up with our angle here clamped between those two things. So what we'll do is go like this. Back to the game manager and we'll see what we're doing. X-axis angle. And we're actually setting it between those two there's ranges there. Alright. So that mathf.lerp between axis angle range x and x-axis angle range .y by this 0 to 1 value we've concocted. And by this I mean that. Alrighty, we can see the tilt is changing. Well, obviously the ballista still doesn't have its tilt action happening, the articulation, so that's still I think the next thing Shane will be doing. Let's pivot around here. Actually, no, wait, am I losing my mind, or did I do this last video? Body bones. We went at 20 degrees. 20. Okay, so this actually needs to be 115. Yeah, so 110. 20 degrees. So not much to work with there, but it's a bit. Yeah, I thought that the tilting action was actually occurring. You know what I'm going to do and consult the previous Every Semicolon video. Into episode 13 I hope. This is only what, last weekend? I don't remember already, so that's pretty cool. I also enjoy the clickety clack. Yeah, the keyboard's great. Yeah, actually I'll do all this. Man, what did I achieve last video? I've entered this prepared. I think I'm probably got some tilt change is now equal to some stuff slowing down. X-axis angle is not equal to previous angle, so if it's not equal to it, that statement is true, and tilt change will be true. If they are equal, then that statement is false, and tilt change will be false. It's all very boring. So this way, it'll only say optimization. Wow, how do people watch this stuff? Okay, that didn't tell me anything because I couldn't bother waiting for the guy. Weapon tilt points, body bind, tilt bind. Let's look at this instead. So my body bind has a tilt point. Yeah, look at that. That's tilting all sorts of crazy shit. Weapon tilt. So where is tilt bone used? Apply tilt. And apply tilt is called by, whoops, blade update, and tilt is changed. That's set by x-axis angle, and that's what I'm using, I believe. X-axis angle. So how could it be changing the angle and not changing that tilt? Let's check to see if it is. Go into the apply tilt method and just verify that this is operating. Applying tilt, but you can see it's not changing, but we can still see that our trajectory indicator does show the change occurring. So we'll just quickly do a bit of that, check the console, just pause it. Do we see? No, nothing. Applying tilt. Current tilt rotation, tilt bone leg rotation. Interesting. Angle T equals x-axis angle, blah blah. What am I missing? So it's definitely the min and max, larger and greater numbers. Why is it not applying the tilt? Let's monitor. Well, we can see that the bone is not moving, so just come over here and just verify that nothing in the transform is changing in the base bone, or is it body bone? Either way. So what changes our trajectory indicator and why is that occurring? Okay, game manager, on GUI update side aim, blah. So if you do it in here, it's all good. We're setting x-axis angle, in the range. Yeah, that should be fine. So where do we draw the, let's go to our projectile trajectory and weapon.x-axis angle is not equal previous show line. Okay, so here's our x-axis angle. All seems to be working fine. Setting it, sets the value. Tilt change is equal to, I got a previous angle is x-axis angle. So tilt change is getting set to true because, or is it? No, it is not. Okay, so tilt change isn't getting set to true, so let's start to narrow this down a little bit. Tilt changed gets set in our property here and set back to true, set back to false here, so never reaches that point. So we can check if it's ever reaching, if this is ever true. So previous angle is that. Do we do anything with x-axis angle. No, game manager doesn't touch it. Let's find out what does. Anything else touch the property? Nope. Anything touch this? Yes. Okay, let's see what's going on. So there's previous angle and x-axis angle. So theoretically they're the same, according to well, since that tilt change is not being set, no, it doesn't seem to be being set. We'll take out, where's that other log? Apply tilt, take that out. Okay. So you can see they always look like they're the same. Nope. See there, it's different. First time it should definitely be different. So previously it was at 25 and then it's at 0. Which point tilt change should have been true. Okay, so now it's just going to quit. Well, it's not going to quit because we're in the editor, but no. So tilt changed must be getting set to true at that point. But perhaps it's happening after late update, or at least at the wrong time for late update. Okay, so it's true there. True there. Alright. Okay, so it's not that, that's fine. So it must be something to do with the order. Did I do any script execution order stuff so far? No. So everything runs at default time. Game manager on GUI. Let's take that out. Let's do it somewhere else. Okay. So it's just to do with when we're doing it in the on GUI method having messed it up. Alright, so now we can see that I can tilt it, change the power, and it's all based on the actual angle of the weapon and my direction from it. So just an hour and 10 minutes now for this video. All I need to do is get it going into working in local space. Right, so I need to know which direction is right and up, which so I'll put in right and up vector 3, and I can transform like that. Let's see if I can get by without actually having to. This is a situation where I probably should have just stuck with this scheme object from the start. this way I don't have to worry about the scale of the aiming collider messing with anything in my local space calculations. So that's cool, and then I'll just grab this and reset its position. Now my sphere actually says 2, so that's also preferable. Yeah, just let's get out of the way a little bit. Okay, now I need to do just a couple of different things. Aiming, side aiming, and back in our weapon script, let's add a couple of different things. I don't need this, because what I'll do is our side aiming will always be pointing forward and up, as you'd expect, so that's cool. Now what I need to do is get rid of this side aiming transform, rename back to our would-be prefab, drag on that, apply that, back to the code, and change things up a little bit. Alright, so hit position local, side aiming transform, reverse transform, blah. So if Z is greater than Z, I'm going to just not worry about world for a bit. Direction to hit point, hit position local, side aiming transform dot position. Need that. I need that. Let's just keep it. So I'm going to normalize that. So our angle can still be vector 3 up. Distance to point, it's fine. Shot force, it's fine. It's all fine. So we want to change this to no, that's probably fine as well. So the final position, and I can just do local position, it's final position. And that didn't work. So it's sitting at 0. So sphere. So local position Z4. Okie dokie. That's not moving at all, or it is. Okay, this is different. So side aiming up, forward, right. Our hit point local is not what we want. Side aiming transform. Oh yeah, it is. Yeah, it's local space in the side aiming transform, which should be this guy. So we click here, you should get that point in local space. So if z is greater than 0, if z equals 0, direction to hit point can just be that, which is fine. Don't need to subtract it from anything, it's already in local space. So we can get the distance, getting that vector's magnitude, normalize that, get the angle from vector 3 up, direction to hit point. Vector 3 up. Let's do side angle transform to up. Where is our... nowhere. This is not working out too well. Best way to debug something like this is probably to just pull back for a sec and just see where things are going wrong. So first let's do this. Okay, so that's just trying to set the button's local position to the hit position in local space, and it's not working. Let's take anything out that could be affecting it. Okay, where is that ball? Practically pretty close to 0. Hit info at point is a world space position. Stop that. Don't know. Wait. Yeah, that's always good. Still had that transform being set to the collider transform, and therefore any local space stuff would have been stuffed. Would have been with that scale. So let's just try that again. Alright, so that works fine. As does this for the most part, except that our ball Z is wrong, because now that's going to be a negative Z. Alright, so the theory is that this will now work on any should now work on any platform. Should be world space independent. Apply that to the ballista. Save, and now we're going to fix up our ballista prefab. Remove its position rotation. I've got to reset the whole thing. It's got no relevant scale. Differences from when you reset. Anyway, so 270. So 00270. Just delete that guy. Ah, that wasn't 00, was it? 130. that X. Okay. And let's just check, what do I need to do? Right. So if our old ballista was that guy, and we started from this guy, went around, so that must be, which one do we start from? Guess it doesn't really matter. I can put them in any order I want. These platforms should not be, yeah, it's just lame. Well, let's just quickly shift these guys out, shift the dwarves along 130, shift them back in. Now what I want to do is make this 130, that's 0. Do the same for this sort of stuff. So I'm going to shift the actual platform itself and everything else be, have 0, local space 0 be in the center of the platform rather than what it is at the moment, which is world 0. So make it a bit easier when I'm placing things on the platform. So negative X. Okay. Now I can just delete catapults, drop in ballistas. Cool. And now just assign these weapons. So we'll start from platform 1 this time. Platform 1, 2, 3, 4. Save that. Save that. Play. Whoa! Shit just got real. One of those platforms. Oh, okay, it was this moving platform, which is this guy. So I must be setting his absolute position. Yep. Okay. What I want to do instead is sort of translate him. For now, I'll just keep the I'll just store the starting position. And let's do a bit of this. Okay. Righto, so we can now whip around and use all these ballistas, and they all work. Okay, so that'll probably do it for this video. Okay, there's that crash again, definitely related to, I'd say, having the ballista bolt falling. So I'm gonna have to resolve that one. pretty soon, because that's no good. I don't really know why it'd be crashing actually, unless there is again something to do with the recording, as that's happened a few times now. The recording has influenced this development in a few different ways, in negative sense. I can't imagine that'd be the case, but a crash in Unity is fairly rare, and only if you're doing something a bit outside of the realm of what Unity is used for typically would you expect to see it. So it's a bit strange. Maybe it could be an infinite loop. I'll try to resolve that one next episode. It should be a fun episode of me constantly killing the Unity process over and over, which is really the only way to exit in this situation. Alright, that'll do it for episode 14. So we've got our ballista now. We can change the power, we can change the trajectory using a much more intuitive control scheme or system, rather than those two horrible sliders. So one thing down and a whole bunch more to go. Thanks for watching.